Today we shall discuss the 8th program in the lab syllabus, that is, develop a program to introduce 2D array manipulation and implement matrix multiplication and ensure the rules of multiplication are checked. So firstly we need to know what is a matrix. A matrix is nothing but a 2D grid of values. This is an example of a matrix of dimensions 3 cross 3. That is, it has 3 rows and 3 columns. So what would be the result if I try to multiply these two matrices? It would result in an error. Actually, it is not possible to multiply these two matrices. Let us see what is the reason behind this. Matrices have dimensions associated with them. For example, this matrix has a dimension of 3 cross 3, that is, it has 3 rows and 3 columns. Whereas the second matrix has the dimension 2 cross 2. It has 2 rows and 2 columns. The condition for matrix multiplication is that the total number of columns of the first matrix should be equal to the total number of rows of the second matrix. In this case, total number of columns of first matrix is 3. Here the total number of rows is 2. They are incompatible matrices for multiplication. If you want two matrices to be multiplied, then these two values should be equal. The number of columns of the first matrix should be equals to the number of rows of the second matrix. This condition is very important and it is applicable when you want to multiply two matrices. Number of columns of matrix 1 should be equals to number of rows of matrix 2. Here is an example where we have two compatible matrices. Although their dimensions are different, we can multiply them because the total number of columns of first matrix is equals to the total number of rows of the second matrix. And the resultant matrix will have a dimension 3 cross 2. If we consider the two input matrices as A and B and the resultant matrix as C, then I can compute the cell C of 0, 0 as the 0th row of A into 0th column of B. Similarly, C of 0, 1 can be computed as row 0 of A into column 1 of B. C of 1, 0 can be computed as row 1 of A into column 0 of B. If you look at these equations, we can identify some patterns over here. I can generalize this as C of ij. If you consider I as any row value and j as any column value, C of ij can be computed as row I of A into column j of B. Consider this, for example, C of 1, 0 equals to row 1 of A into column 0 of B. This is how we can generalize the computation of each cell of the result. And therefore, I will be making use of a nested for loop to implement the computation of matrix multiplication. Here the first loop, the I loop, is to iterate over each row. I want each row to be multiplied with each column of matrix B. The I for loop is used to iterate over the different rows of matrix A. So I equals to 0, I less than number of rows of A. It is used to iterate over the different rows of matrix A. The J loop is used to iterate over the different columns of matrix B. So basically, the value of I is going to lock the row number. The value of J is going to lock the column number of B. We are going to multiply a particular row with a particular column at a time to get some value at the resultant matrix. That is why we have two for loops here. I locks the row number, J locks the column number of the second matrix. And then C of ij. 0th row into 0th column will give me the output at C of 0, 0. So I initialize, at the beginning I initialize the value of C of ij to 0. We have not yet started the computation, so initially I will set it to 0. Now multiplying a row and a column involves multiplying 1 into 2 plus 2 into 1 plus 3 into 3. And then we have this line of code for the K loop. K loop is used to iterate over each element of row I into each element of column J. That is, this is how the computation is going to proceed. This part of the computation is taken care of by the K loop. So K is going to multiply a particular element from this row into a particular element from this iteration of multiplication is taken care of by the K loop. I is the row number of matrix A, J is the column number of matrix B, and then K indicates these values. Initially the value of all three are 0. So C of 0 0 equals to A of 0K, A of 0 0 into B of 0 0. This will give us 1 into 2 equals to 2. So C of ij plus or equals to. Previously the value of C of ij was set to 0. Now it becomes 0 plus 2. During the next iteration of the K loop, the value of K is incremented by 1. So now we will be multiplying 2 into 1. Previous value of Cij was 2. So 2 plus 2 equals to 4. Next 4 plus 3 into 3. 4 plus 9 is 13. This is how we are going to proceed with multiplying a row and a column using this for loop. We are making use of nested for loops and we have 3 for loops in line. Now let us write a simple program to implement our matrix multiplication.